Today's video on page 4. The first thing I would do is I would put SOHCAHTOA on top of your page because you're going to need both sine and cosine, opposite over hypotenuse for sine and for cosine adjacent over hypotenuse in order to complete these problems. I'm going to do number 1 and 2, and then I suggest that you hit pause and try the rest of the page yourself. The methodology should be the same for all of these problems. Now, when I look at number 1, it says, what are the approximate coordinates of point P? So I'm going to go to point P on the graph, and I'm going to highlight it, and I'm going to say from the graph, if I'm approximating x and y, I'm going to look at the triangle that's drawn inside the circle, and I'm going to see that x is approximately 0.7, and that the y value is also 0.7. If I look at the triangle, I can see from where it hits the circle at P, that is a radius, but there's also a radius down here. And I can see that that radius is 1. And so for all of these problems, you're going to assume that we are doing the unit circle, and in the unit circle, the radius is always 1, and you can confirm that by looking at every graph for your problems. When it is asking for the approximate value of cosine, it is asking for us to do using this x and y are adjacent over hypotenuse, or cosine is also known, if you remember, as x over r. So if the x value is 0.7 and the r value is 1, it's 0.7 as the approximate value of cosine. For sine, one definition is opposite over hypotenuse, also known as y over r. The y value approximately is 0.7, the radius is 1, and so the answer for the approximate value for sine is 0.7. Now when I look at the end of problem 2, where it says what's the exact value of cosine, that's telling us that the angle pi over 4 is giving us a clue that this is a special right triangle. Pi over 4 is the same as 45, and on a previous page I told you 45, 45, 90 is a special right triangle with sides of 1, 1, and square root of 2, which I drew over here. But if you have not memorized these special triangles yet, then what you have to do, at least in the interim, is you're going to have to use Pythagorean to find the exact values of the x and y of that triangle. So using Pythagorean, I can use x squared plus y squared equals r squared. That's also the equation of a circle, if you remember. Since the x and y are the same approximate value, that means they're going to be the same exact value. So when I'm doing Pythagorean, rather than say x squared plus y squared, I'm going to change that to x squared plus x squared equals 1. So that's 2x squared equals 1, dividing by 2, x squared equals a half. And when I square root both sides, I get plus or minus 1 over square root of 2. Now, I don't need the negative version of that because I'm in quadrant 1 where everything is positive. So now when it asks what is the exact value of cosine pi over 4, well, the exact value is going to be using your special triangle where one side is 1, if I'm standing over here where it's 45 degrees or pi over 4, it's going to be adjacent over hypotenuse 1 over square root of 2. And for now, we're not really going to ask you to rationalize that, meaning move the square root of 2 to the numerator. The same exact value is going to be for sine of pi over 4 because this triangle has both 45-degree angles. So whether I'm doing adjacent over hypotenuse or opposite over hypotenuse, it's still going to be 1 over square root of 2. So this is how you do these problems, and I suggest that you hit pause and complete this page before I expose these answers. So here are the answers to 3 and 4. This is another special triangle. How do I know? Pi over 3 is the same as 60 degrees. So I know if it's a right triangle, then the angles have to be 30, 60, 90, and the sides have to be correspondingly 1 for the 30-degree angle, square root of 3 for the 60-degree angle, and 2 across from the 90-degree angle. So either using Pythagorean or my special right triangle, I can do the exact values of cosine and sine. Number 5 is interesting because the angle they give you is pi over 6. Pi over 6 is 30 degrees. And if you remember from the previous question above for number 4, that was a 30, 60, 90 right triangle. If this is a 30-degree angle, then I can use all the information I did on number 4 and 5 to calculate all of these things. Obviously, the approximate values come from the graph. The radius is still 1, but I can use the same triangle that I did above to do the exact values of sine and cosine of pi over 6, otherwise known as 30 degrees. Page 5 does not require me to explain much except to introduce some new trig relationships, including the definition of your 3 new trig functions. Cosecant is the reciprocal of sine. So when I do 1 over sine, that is going to be the same as a ratio for cosecant. Secant is the reciprocal of cosine. So that means when I do 1 over cosine, I am talking about a ratio produced using secant. Cotan is the reciprocal of tan. So 1 over tan is the same as cotan. Tan and cotan are easy to memorize as reciprocals because they both have the word tan or tangent in it. But the way I memorize secant and cosine as reciprocal and cosecant and sine as reciprocal is I remember C always goes with S. So the new one I'm learning, cosecant, has a C, and that's going to go with the one I already know, sine. Secant begins with S, so I know it's going to go with the trig function I already know, cosine. So CS, CS, and tangent and cotangent have the same words in it. In addition to the reciprocal triangle ratios, we also have these relationships. So if I'm doing cosecant, and cosecant is 1 over sine, then rather than opposite over hypotenuse for SOHCAHTOA, I'm going to do hypotenuse over opposite since you have to flip the fraction. Same thing with secant. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. The reciprocal would be hypotenuse over adjacent. Cotan is adjacent over opposite because it's the reciprocal of tangent, and tangent is opposite over adjacent. So again, when I was talking about the first reciprocal relationships above, you're always taking cosecant and doing 1 over its reciprocal to describe the relationship. The same thing you would do with secant theta equals 1 over cosine theta, and cotan theta is 1 over tan theta. Now, these are the verbal descriptions and a mathematical relationship. And below here, I'm not going to go over this too much, but you should pay attention to common calculator errors. First of all, and most egregious, is making sure your mode is in the correct place. When you do pre-calculus, we are almost almost always in radians. So you must go to mode in your calculator and you must make sure that your mode is in radians, because as you can see, doing the sine of 10 degrees versus 10 radians is going to give you different answers. And then there is something that looks like an inverse button over here, and you have to be careful. This inverse button has to do with 1 over something. It is not the same as inverse. You can see inverse here, inverse sine, inverse cosine, inverse tan, which we will study in a later packet. So you've got to be careful when you are doing cotan, secant, and cosecant. What I always make sure I do, so I don't make a mistake, is I do 1 over sine when I'm doing cosecant, 1 over cosine when I am doing secant, and 1 over tangent when I am doing cotangent. Please be careful. And then, as always, we always tell you the calculator is stupid, so you have to be smart. You have to make sure you use your parentheses properly. 30 is like the argument in a log. It needs to be enclosed by a parenthesis. Sine of 30 in parentheses is going to be a different answer than sine of 30 plus 2 in parentheses, and both of those are going to be different from sine of 30 plus 2. So please be careful, memorize these common calculator errors, even though at first you will not be using a calculator. Page 6. Fill in the chart below with exact values. We are not going to worry about the calculator. I crossed out the part that said decimal approximations. So one thing I did was, these are measurements in radians, and just because you are learning, and eventually you cannot keep converting between degrees and radians, I put the degree measurements to help you with your special right triangles. So pi over 6 is the same as 30 degrees. Pi over 4 is the same as 45 degrees. Pi over 3 is the same as 60 degrees. So I'm going to need 2 special right triangles to come up with the exact ratios. This is similar to page 4. So here is my one right triangle. I'm going to put 30 here. I'm going to put 60 here. And remember, because it is a Pythagorean triple or a special right triangle, I know that across from 30 is a measurement of 1, across from 90 is a measurement of 2, and across from 60 degrees is square root of 3. So now I can do my cosine ratios. Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. Tan is opposite over adjacent. Secant is going to be the reciprocal of cosine. So that's going to be hypotenuse over adjacent. Cosecant is the reciprocal of sine. So that's going to be hypotenuse over opposite. And cotan is the reciprocal of tan. So rather than opposite over adjacent, it's going to be adjacent over opposite. So now you're just going to use that special triangle for 2 different columns. 30 and 60 are luckily in this same special right triangle. So when you do the ratios, you just have to pull them off of that triangle there. So here are the answers for 30 degrees. I don't know if you can see them all. I'll move it down in a minute. Don't worry about rationaling at this point. Just get the correct ratio. We'll worry about rationalization later. And then lastly, here's the answer to cotan. Now, because we use the same triangle for the 60-degree angle, I'm going to expose that as well. Again, do not worry about rationalizing. Square root of 3 over 2 is fine. Square root of 3 over 3, I'm sorry, 1 over square root of 3 is fine for now. 2 over square root of 3 is fine. Do not worry about rationalizing. When I've got my 45-degree angle, that's a completely different special right triangle. That one is going to be a 45, 45, 90 right triangle. 45, 45, 90. Across from 45 is 1. Across from 45 is 1. And square root of 2. Now I can use my same ratios for cosine, sine, tangent, etc. to use this special right triangle that I did in purple in order to do the ratios for pi over 4, which is the same as 45 degrees. Here are the answers. Again, don't worry about rationalizing. Memorize those two triangles. If you memorize those two triangles, then you will see that you will have a much easier time when we start learning the unit circle. So, of course, we've got our what do you notice, what do you wonder question, and this is what I would write here. Why do the values repeat? Well, first of all, the reflections over the unit circle, but we'll learn that in a few lessons. But they're also complementary angles, meaning they add up to 90 degrees within the same triangle. So 30 and 60, you're going to see the same ratios over and over again because they're from the same triangle. And they're complementary because the cosine of pi over 6, which is adjacent over hypotenuse, is the same thing as saying the sine of pi over 3, which is opposite over hypotenuse. They're using the same sides of the same right triangle. Okay, last part is, this says warm up, but I'm going to do it since I'm on this page here. So it asks, find the degrees in both, find the measurement of the angle. That's what this theta means here. Theta means find the angle. Remember, it's just like log. Answer to a log is an exponent. The answer to a sine, cosine, tangent, etc., that's a ratio. But when they say find theta, that's like doing an inverse. They do not want you to find the ratio. They give you the ratio. They want you to find the corresponding angle that produces that ratio. What angle produces these ratios? So it's 1 over 2. I know my special right triangles. If it's 1 over 2 and it's opposite over hypotenuse, I'm standing here. Little stick figure is standing here for the special right triangle. Across from him is 1, and the hypotenuse is 2 because sine is opposite over hypotenuse. And so I know that if I have a sine ratio of 1/2, I have a 30, 60, 90 right triangle, and I'm standing at 30. And also the radian measurement, the same, is pi over 6. For B, I know that you should probably hit pause here and try B. I'll do C and D with you. But from B, you should recognize that that is not a 30, 60, 90. Those are the measurements. As soon as you see that square root of 2, those are the measurements associated with a 45, 45, 90 right triangle. And so here are the calculations for that. I draw my triangle. And I know that if it's square root of 2 over 2, if I multiply the top and bottom by square root of 2 over square root of 2, it's the same as 1 over square root of 2. So whether I'm standing over here or over here, remember with a 45, 45, 90, the cosine and sine ratios are going to be the same because the angle measurements are the same. So I'm going to say that regardless of where I'm standing, since the ratio is square root of 2 over 2 or 1 over square root of 2, my angle measurements are 45 or pi over 4. Okay, Cosine of 1. Cosine of 1 does not have a ratio, so I need a denominator. The denominator, because we're dealing with the unit circle, the denominator is going to be the hypotenuse. The hypotenuse is the radius. The radius is 1. So I make a ratio for the cosine theta question. And then I'm going to notice that for this, if I have a cosine ratio of 1 over 1, this means that I am not forming a triangle. I am still on the x-axis and I have not rotated. How do I know? Because cosine is x over r, and the x value is 1 and the r value is 1. So in order to produce a ratio of 1 over 1, I can say that my angle, since I do not rotate at all, my angle is going to be 0 degrees or 0 radians. The same thing is going to happen with sine theta equals 0. No denominator or ratio, so I put it over 1. Sine is y over r, so that means the y value is going to be 0 and the radius is 1. So I'm in one of two different places here. I am either on the positive side of the x-axis without rotating, or I have rotated to the other side of the x-axis where it is the negative side of the x-axis. How do I know that? Because y equals 0 for both of these places. I don't care about x. It's sine. Sine only is concerned with y. So once I have written down where I've rotated to, including my knowing what my radius is, sine is y over r, 0 over 1. So it is one of two angles. If I stay on the positive side of the x-axis, it's 0 degrees or 0 radians. If I rotate 180 degrees to the other side of the x-axis where the x values are negative, then that 180 degree rotation is obviously theta equals 180, or in radians it's going to be pi. So theta would be pi. Okay, this finishes part 6. Page 6. Another video is coming.